in this video, we're going to be making it specifically for M104 at IUK. It's going to deal with the story problems that are in section 3-2A and 3-2B. We are writing a system of linear equations to solve all of these different story problems, and this is another one that deals with the previous example that I just dealt with a tailwind and a headwind. This one is going to be referring to a boat in water, and you are going up against the current or you're going with the current, which again is going to affect the speed of the boat. Alright, and this approach is going to be a little bit different, more straightforward like the other systems of equations that we have done, alright, as far as writing that systems of equations. Alright, so let's go ahead and read and get started here. It says a family is canoeing downstream, which means with the current. If you're going downstream, the current is with you. Alright, so that means it's going to be pushing you and making you go a little bit faster. Their speed relative to the banks of the river averages 2.75 miles per hour. During the return trip, they paddle upstream or against the current, which is going to be slowing them down a little bit. They're averaging 1.5 miles per hour relative to the riverbank, okay, on that return trip. Find the family's paddling speed in still water. Find the speed of the current of the river. Alright, so as always, we start by defining our variables, and then we write our system of equations, and then we choose to either solve by substitution or elimination, whichever one happens to be the easiest way to go about doing that. Okay, so I'm going to start by defining my variables. Alright, we always start by looking to see what the question asks for. Find the family's paddling speed in still water. Okay, so speed in still water. Find the speed of the current of the river. Okay, so there's our two things we're looking for. So x is going to be the speed in still water, and our y is going to be the speed of the current of the river. Okay, the speed of the current. Okay, now we need to write our system. Alright, now basically on this one, we've got two scenarios going on here. We're either going with the current or we're going against the current. So that's going to be where my two equations come from. My first one, I want to base it on the speed with the current. Okay, so if it's with the current, it's going to speed me up. Okay, so speed in the still water plus the speed of the current. Alright, it's going to speed me up, right? So with the current, we were averaging 2.75 miles per hour. So x plus y is equal to 2.75. Okay, now going the other way against the current, it's going to slow me down. We were averaging 1.5 miles per hour. So x minus y equals 1.5. Okay, so there you're taking into consideration that when you're going with the current, it speeds you up, and when you're going against the current, it slows you down. So there's our system of equations. Alright, now after you get that, which is the hardest part of this entire type of problem, is defining those variables and writing that system of equations. From there, you just have to solve it. And again, I normally do substitution. However, with those y's having opposite signs right there, it makes elimination really nice. So we're going to choose to do elimination. Alright, which basically means I'm going to start and I'm going to add those two equations together. So I've got x plus y is equal to 2.75. I'm going to add to that x minus y is equal to 1.5. Alright, so when I add those two together, those y's are going to fall out, which is what we want to happen. I'm going to have 2x is equal to a 4.25. Going ahead and dividing by 2, I'm going to have x equals 2.125. Obviously, you're probably going to use a calculator to get that. Alright, now I've already got my x right there, so I've got my speed in still water. Now I need to find y, so I'm going to plug it back into the original equation. Okay, so substitute. Substitution. Substitute into original equation. Okay, so In all honesty, it doesn't matter which one I use. I'm going to go ahead and use that top one. I'm going to do x plus y is equal to 2.75. I know what x is, so x is 2.125 plus y is equal to 2.75. I'm going to go ahead and subtract from this from both sides of the equation. That's going to give me a y equal to a 0.625. Okay, so I know that this is my speed of the current. Okay, so this one, actually the solving with elimination made this one pretty straightforward here. So again, I always summarize what I've got here. Alright, so the family's paddling speed in still water is that 2.7 or 2.125 miles per hour. So we can be a little more specific here. Paddling speed in still water is the 2.125 miles per hour. Alright, and then speed of current is the 0.625 miles per hour. Alright, and I always do, after solving one of these, I always do pull out all of the information away from the work and write it in a summary box so that you can clearly say that, oh hey, you've answered this question and have all the pieces that you need. Okay, so again, pretty straightforward. This is the second example that I did make a video on, dealing with that, you know, going against the current or with the current, or going against a headwind or, you know, with the headwind, because you just have to kind of think through these a little bit to be able to write the system for these. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too, and don't forget to subscribe to the channel. Thanks.